R. R into R is R square. Under root of R square is R. That means under root of AVE is R. This AVE is average R square. AVE is average R square. R is average of R. This average of R should be greater than R, and STMT must be below 85. So this you have already done yesterday, reflective and formative. Today, I will be conducting above this phenomena, that is, let me talk about formative quickly. In formative construct, when the items are having causal relationship between the construct, here we get beta. Beta is called as outer weight. And reflective we call it as outer loading. Outer loading is in reflective, outer weight is in formative. So this is trust. You have to create fourth item of trust. You have to create fourth item of construct, which is called as global item. Global item is overall item. Researcher has to create fourth item. Overall, how much trust you have in the smartphones? Overall, how much trust you have in the higher education system? That you have to prepare. And then trust leads to overall item. This beta should be 70 and above. If this beta is 70 and above, convergent validity of formative indicators is established. My formative items must converge into my overall item. Global is overall item. Just like moral of the story. Thirsty Crow story must converge into moral of the story. Where there is a will, there is a way. You read entire story or you read moral of the story. Moral of the story is overall global item. If you miss this global item, then you are in a big soup, because construct is formative and you have not created that global item. You have to ask this global item in questionnaire. So be aware that you should create global item. This process is called as redundancy analysis. This process is called as redundancy analysis. Second is, these outer weight must be discriminant to each other. Outer weight, that means VIF outer should be less than 3. Every beta should be independent of each other. Every beta should be independent of each other. For example, this is food, this is clothing, and this is shelter. Food, clothing, and shelter is physiological needs. So physiological needs, food is different, cloth is different, shelter is different. Their variance inflation factor should be less than 3. If it is less than 3, you can safely say all the 3 are different. Food and cloth are not same. Right? This is discriminant validity. Next is third and the last. All these outer weights must be significant. All these outer weight must be significant at any cost. Food must be significant. Just like the name of the construct is God. You know what is the R square of God? What is the R square of God? God is 1. सुना है सबने? Have you heard God is 1? So R square is 1. God is 1. How many gods are there in under Hindu mythology? 33 crores. And you summarize these 33 into 3 gods: Brahma, Vishnu, Mahesh. That's it. That means these are the 3 gods which are forming a phenomena and a construct which is formative construct, and R square is always 1. When the R square is 1, it is called as composite variable. Composite means there is no error. Is there any error in the God? No. Our Hindu mythology has clearly defined destroyer, preserver, creator. So God is 1. Formative means you cannot delete any God, you cannot add any fourth God also. Right? You cannot add, you cannot delete. So outer weight must be significant. Brahma must be significant, Vishnu must be significant. If they are not significant, then what you have to check? You have to check what is the, if it is not. What is the outer loading of Brahma, Vishnu, Mahesh? Outer loading. What is the outer loading? They must be above 50. They must be above 50. If the factor loading of these three formative construct loading, if weight is not significant, then you check whether they are relevant to me or not. If the factor loading is 50 and above, they are relevant. You can move ahead to the next step, SEM. If the value is less than 50, if it is less than 50, then you have to check P value. Is P value significant? Outer loading must be significant. If outer loading is significant, you can move ahead with your formative construct. But if outer weight is insignificant, outer loading is less than 50, outer loading is also insignificant, then only you can delete formative construct item. Right? You know, in present time, due to begging, if you see what are the parameters and characteristics of beggars, are they wearing clothes? No, bare minimum clothes they are wearing. They are surviving only on food and shelter. Yeah, they need bus stand and they need basic food. So hardly. That means their outer weight is insignificant, outer loading is also insignificant. They don't care about clothing. If they wear good clothes, who will give them money? It's a good business in Mumbai. People are crorpatis, beggars. The thing is, when formative construct can be deleted, when constructed item can be deleted, check the weight, check the loading, check significant. These are the guidelines given by Hare et al. 2022 and 24. Right? First book, I'll give you the first book. It is freely available. Third is also freely available. Is there in the market or soft copy. These lines, you should write these lines with page number. You all are supposed to write these lines with page number. Hmm? Let me just give you the page number also handling formative. Okay, just see formative. So napkin what is napkin. So if formative is there, these are the only things. Look at your screen. Step 1, convergent validity. Step 2, VIF outer. And step 3, significance and relevance of formative indicator. These are the only three guidelines of formative. If you are working with formative, it is very important construct for you. You need to operationalize them very carefully. Formatives are very important constructs and they are far because R square, you are working with R square, that means you have measured a phenomena which has captured everything. R square 1 means something big. Parshuramman scale is now R square 1, tangibility, reliability, responsiveness. None of the researcher has given sixth construct and 23rd item. It is formative. Big five is formative. Maslow 5 need formative. So if you are finding any formative, you are doing something, good level of research. 4 items. This is 4 items. Formative, create global item or global items. Create global item or global items. If you have created global item, then this P11 relationship should be more than 70 and above. This is the only way to show convergent validity of formative construct. So Professor Ringel's note is there. These are the slides of Professor Ringel, what they're teaching in Hamburg. Right? Step 1. Step 2, formative to reflective. Just like utility. For example, that construct is utility. It has got 4 items formative. I have to create fifth one. Fifth one is utility global. GLO means global. Overall essence of the utility. Utility means hospital. Utility means school. Utility. This is for data set which is of smart city. In a smart city, utility must be there. Park should be there. Hospital should be there. School should be there. Police station should be there. Right? But overall utility is 1 item. This relationship should be 70 and above. Here it is 840. This has to be reported in the research paper that my 4 items converge into my overall item. This is DV. Smart city is DV. Utility is IDV, but convergent of formative is done like this. Collinearity assessment is VIF outer. VIF outer should be less than 5 to a liberal method. Liberal. I have given you strict method of 3. You can take a liberal criteria of 5. Liberal criteria of 5 as far as here at all 2022 book is concerned. Right? In software, you will get these values like this. I've shared this PPT with you. You can open this slide number 9. In slide number 9, you will see we will get these values when we will operate software. Weight must be significant. Weight must be significant. Look at the flow chart. If you see the flow chart, let me just zoom it for all. Flow chart says that outer weight must be significant. If they are significant, your job is done. But if they are not significant, check outer loading. If outer loading is more than 50, then you can retain the formative item. If outer loading is more than 50, keep the indicator. But if the outer loading is less than 50, check the p value. Check the p value. If p value is significant, retain the item. But if outer loading is insignificant, outer weight is insignificant, you have to delete the indicator. Delete it. And then come with food and shelter. Right? Then you have to justify that your audience says we don't need this clothing. Your respondents are such. Sometimes investors say, I don't want FD. होता है ना, लालच आता है ना, म्यूचुअल फंड में 14% रिटर्न है, गोल्ड में कितना रिटर्न है, वो कहता है मैं नहीं एफडी करता. अब एफडी एक इंपॉर्टेंट क्राइटेरिया है. एफडी नहीं चाहिए उसको, मतलब नहीं चाहिए उसका. आउटर सिग्निफिकेंट विल बी लेस, आउटर वेट विल बी लेस. राइट? सो दिस कैन हैपन विद यू. You worked with the formative, but you may delete. This will be the rarest of the rarest phenomena which you can encounter, but you can encounter. So you should be ready with these 3 slides. Right? Yes. No. You started with 5 items of reflective construct, and factor loading was 30-20, 30-20. Number 1 is data is poor, right? People are outliers. Number 2 is that you have deleted 4 items out of 5 and you are left with 1 item. Yes, you can go to maximum, you can delete 4. You can work with single item construct. You have to show the procedure why they were deleted. Yes, you have to show those low factor loadings. In many of our papers, we have written with the asterisk. We started with 7 items, 2 were deleted, 5 were there, but we show 2 factor loading also with an asterisk. And in the note, we write deleted from the final analysis. You have to show.
Sir, I request if you can explain this global item once more.
Global item, look at this global item. Can you see inverted commas? In this slide, inverted commas. A construct is CSR. The name of this formative construct is CSR. So Marco Arstedt in 2013, they wrote a paper measuring reputation in global market, a comparison of reputation measures. They said, everybody can use this prefix. Please assess to what extent you believe in CSR activities of the companies. For example, your construct is loyalty. So you can frame, please assess to what extent you are loyal to your organization. If your formative construct is customer satisfaction, please assess to what extent you are satisfied from our financial services. Right? This is covering the overall essence of the construct. Right? So this inverted commas has to be asked by me in addition to 4 items in the questionnaire. And then I have to say these 4 items are converging into my overall item. Overall.
So you mentioned this this outer arrow at the end, and when you were showing this, so
this one reflective.
Not this one, sir. So you showed one more model where there was utility.
This one.
So
there is reflective.
Utility global.
Utility global. Look at the arrow from where the arrows are going. 4 items of utility are converging into overall utility. There is redundancy analysis. So in a SAM model, we have also shown redundancy analysis also. Every formative, if you have got 10 construct and 6 are formative, you have to prepare 6 global items. You cannot say, look, I don't know. I have formative, but I have not created global. That is a wrong statement. When you know that this is the citation, two citation, this is one of the citation, Marco Arset, two is here at all 2022. They are saying that you have to create a global item. Every formative must have a global item, means overall essence, right? It can be items or item. So preferably they have said that even in their research paper 2019 they have created one item. Global item has to be one. So this is reflective and formative. Coming back to the smart PLS. Okay, just have a look at kindly see what we are going to do in the next 30 minutes. Please open your smart PLS interface. We are going to work with a very common model, but we will do it differently. Okay. The name of the model is corporate reputation model. The name of the model is corporate reputation model. And in corporate reputation model, the main construct is customer loyalty, CL. Okay. Watch carefully the screen. Customer loyalty. Customer loyalty is my Y1, right? When all the independent variable are zero, when all independent variables are zero, what is Y? Y is equal to alpha. अगर दुनिया में कुछ नहीं है तो अल्फा तो है ना, कांस्टेंट इज देयर, द बेयर मिनिमम. इफ आई कैन नॉट डू एनीथिंग, एडवर्टीजमेंट, प्राइस का, पैकेजिंग का, कुछ तो सेल कर ही लूंगा दरी बिछा के. Y is equal to alpha. So Y is equal to alpha if all the independent variables are zero. So this is the scenario customer loyalty. I am again repeating what I have said in the morning. Your journey will start from DV. Your journey will not start from IDV. People run away against the factors. I am finding IDV. This I am always asking what these IDVs will lead to. They have no answers. People don't have answers. You have to say purchase intention, adoption intention, turnover intention, destination love, destination image, customer satisfaction, word of mouth. There are so many things. You have to start from here. So customer loyalty is dependent upon customer satisfaction. This is X1, right? This is X1. And the competence of the company may lead to customer loyalty. This is X2, two independent variables, right? Competence also leads to customer satisfaction. If you are competent, your customer satisfaction will be there. If you are competent, the public will be loyal to you. It can be applied under political marketing. In political marketing, people vote for a particular party every 5 years because party is competent and people are satisfied from the government, right? This is thing then. So this customer satisfaction is playing dual role. This is playing Y2 also. This is playing the role of Y2 also. Satisfaction is dependent variable for competence and satisfaction is independent variable for loyalty. When you have multiple dependent variable and multiple independent variables, then SAM is applied. Okay. When SAM is applied, people ask, in the final Viva, a very basic question and people fail. They say that you could have done this with regression. Why you have gone with the Lord of Tamjam? Right? You should have done with this as PSS. You say, sir, I have got multiple dependent variables and even dependent variables are related to each other. Look at Y1, Y2. Aren't they related to each other? Satisfaction, Y2 is leading to Y1. In such a complex relationship, customer satisfaction is also playing the role of mediator. When somebody is playing multiple roles, dependent, independent, mediator, SAM is bound to happen. So don't say that I should run only SPSS regression. I will apply because it's a model. Second variable is people like you. If people like you, then they are loyal to you. Some people like particular parties from their generations. Some people like Colgate since last 40 years. So they buy, they don't say, please give me toothpaste. They say, give me Colgate. And they buy Pepsodent. But they will say Colgate. Colgate is toothpaste, right? You like because your forefathers and generations were using Colgate. So you are using Colgate. So if you like, you are loyal. If you like, you are also thinking that I am satisfied from this product, service, party, or country, or anything. So this is another X3, X3, right? There are three independent variable, and there are how many dependent variables? Three IDV and two DVs, two DVs, and there is a mediation also, right? So in corporate reputation, there are four variables. Look at these four variables, right? One is quality. You are creating quality products, therefore you are competent. You create quality products, therefore people like you. CSR, you are doing CSR. Draw this thing in your copy also. CSR, if you do CSR, you are competent. If you do CSR, you like your company. Third is performance. Your product is performing. Geo is performing. Then the Airtel. Many times Geo is performing. Therefore, you say that Geo is more competent. And that is why I like Geo. This happens, right? Sony is better than any other company because the performance is super. You like, and because it is competent, right? Third is attractiveness. Okay. So attractiveness also leads to competence and also leads to likeness. I'm not sure about this name, but now tell me where you will start hypothesis. How you will create hypothesis. How you will create hypothesis. So everybody just focus on we are here. I just said you have to start from Y1, right? Y1. And then you have to ask whether my constructs are reflective constructs or formative construct. The relationship of construct with its item is called as, what is the name of this relationship? The relationship of construct with its item is called as, I'm repeating question. The relationship of a construct with its item is called as outer model. Okay, this is an outer model. This is an outer model, and CFA is done on outer model. So never ever cross the things of outer model with inner model. The measurement model assessment is to be applied on outer model, right? This should be there. For example, quality has got two items. Quality has got two items. Is it a reflective construct or formative construct? This is a reflective construct, and it is also called as outer model. We have got outer model. This is an outer model. The relationship of competence, likeness, and customer loyalty. This is called as inner model, right? The relationship of construct to construct is called as inner model. So if you say that I am applying CFA, then CFA is applied on outer model. Outer model is CFA, and on inner model, the inner model, you will apply SEM. And this is inner model is nothing but hypothesis testing. This is what? This is hypothesis testing. So reflective has got 5, 6 criterias. Formative has got 3 criteria, but SAM will have 6, 7 criteria. Write down those 7 criteria. We are supposed to check out one by one, right? What are those 7 criteria? So, if you are talking about SAM, the number one is you have to show VIF inner. VIF inner. VIF inner is representing that there is no multicollinearity. There is no multicollinearity among the constructs. Between construct to construct, there is no multicollinearity. High correlation is an issue in cross-sectional data. So the first thing first is there is no multicollinearity among constructs, not items. I'm not talking about items and the construct. Construct to construct. Competence to likeness, competence to customer satisfaction, customer satisfaction. So multicollinearity can be tolerated till the tune of 5. Maximum tolerance limit is 5. If it is more than 5, data is an issue. Your data collection is an issue. Bring more data set. Bring more data set. So VIF inner should be reported number 1. Number 2, you are supposed to show R square of final DV. There will be so many R square. People are very happy to show I have got 4 R square. Right? They're very happy. Only DV's R square is required. What is the final DV here in this model? Customer loyalty. You will get DV at competence. You will get DV at satisfaction, likeness. But the only important DV is customer loyalty. So R square, what is the guidelines of R square? Close to 1 means you are God. You have determined everything. There is, after 2021, no research is required. Right? What is R square of DV in social sciences? क्या होती है social sciences में? Anybody from the audience? What is the R square of social sciences? Priyanka says 1. No, Priyanka. R square 1 is of formative construct, that is outer model. Inner model. Pooja said 50%. Sarthak said 50%. Sana said more than 20%. Greater than 15%. 1-5. 5050. Ritesh said 70. Anything else? Anybody would like to? Monu? Yes, Monu, type it. What do you think? What is ideal R square of social sciences? Marketing, finance, HR. कितना हो सकता है? कितना हो सकता है?
Good afternoon, sir.
Yes, please speak.
Okay.
You're audible.
Sir, actually, R square values is provided by the different authors. There are different values. Like Falk and Miller 1992 has given 0.10, Cohen 1998 given 2.6 is substantial, Chin 1998 0.67, and here ATL 2011 has provided R square value 0.75, 0.50, and 0.25. Like 0.75 is being considered as substantial. Yeah, 0.50 moderate and 0.25 is weak. So my question is also there regarding to this. So different authors has given different values for R square. So which one we should apply in our like results analysis? Yeah.
Question समझ आया सबको? Which is the ideal R square? Because we are supposed to tell R square in front of the panel or in front of the editor or reviewer. He will say, this is your R square. Right? Questioning can be done on R square. You have created a very big model out of 2 years. Your synopsis has been created. You have collected data. And you are coming up with 30, 20, 25 R square. And eventually after 4-5 years, the professors are saying, go back and do another PhD because this R square is a very poor R square. Will you do this? No. Can you see the screen? Every R square is a rough guideline. There is no set standard for R square. Coefficient of determination, first of all, after reliability and validity, your task is to determine. But what is the tentative guideline? So you have to go back to your TCCM framework, right? I said that this is going to be very, very crucial for frameworks, theory, context, characteristics, methods, antecedents, decisions. Try to write down R squares also. What were the R squares of these studies? Let us say you have finalized 135 papers for your thesis. Your references covers 135 research papers. 135 means 135 R square. 135 paper means 135 R square. Note down those R square in the Excel. Sort them. Sort them in ascending order from smaller to the larger. Smaller to the largest R square. You have to show your R square with your own benchmark. You are the one who is bringing this thesis. You are the one who is saying in the entire world, these are the 135 papers, those were crucial for me. Because of these 135, I have created a hypothesis. Those 135 must have given you R square. So let us say you have got 135 R squares because there were 135 finalized paper and the smaller R square was 10% and the biggest R square was 50%. Then you say my R square is 22%, 17%, 30%, 39%. Therefore, I am well within the population. This is the population of customer loyalty. Entire world is saying that the R squares range from 10 to 50%, and I am getting how much R square? I am getting 20% R square. Therefore, I am doing a good justice to my zone. Will I say that? Will a good professor will say bring more than 50 because word has not gone 50 and above? It is not. You have to tell that how word is behaving. My results are similar to these ranges. There is no benchmark, but you have to create your own benchmark because you are the one who are bringing good papers in literature review. Can you say I am doing bad literature review? My references are okay kind of. Never ever you will say. You will say I have selected top papers and all those top papers have given this range and my R square is matching up to this range. This is how you have to justify even the low R square. Low R square, right? In one of the paper, everybody just note down one of the paper, scholar.google. I'm writing a name of a professor. Please write down. You should also use this professor as a Bible, right?
Sir,
Yes.
sir, if the R square value is more than 0.10, then it is okay
It's
then.
a spurious regression. I don't know how R square can be more than 1. The maximum range
Mm.
is 0 to 1 R square. Can you go beyond the specified ranges? I mean, maximum range of factor loading correlation is -1 to +1. R is -1 to +1. Coefficient of determination is 0 to 1. R square cannot be more than 0 to 1, right? It cannot be. So make sure that your calculation error is there. It's not that uh, your model is wrong. Your calculation is wrong. So everybody should write down Professor Rasuli Manish, Mustafa Rasuli Manish, right? In search, Mustafa Rasuli Manish. This is the name of professor. He has got 13,122 citation. He has shifted his base from Malaysia to Perth, right? And his papers are best on PLSM and FSQCA. We also learn from his papers. We read his papers. We read his papers on R square. In one of the paper, he said in social sciences, as low as 9%, 10% R square is acceptable with a citation. right? So let me just see. There is a paper of Airbnb, I guess, right? Airbnb. His paper of Airbnb. You should try to find out. In that paper, he has mentioned about the aspect of that lower R square is acceptable in social sciences. Our objective is that determination should be good, but number should be more than 70, 80. You are heading towards unity. You are heading towards, something which is equivalent to God, right? You cannot say that I have determined everything. What will other researcher do in the upcoming years? If your R square is 1 or more than 1, first of all, it cannot be more than 1. The range is 0 to 1. But his paper should be followed blindly, because everywhere he has written about low R square, social sciences, low R square. Citations are there. Follow this professor. You have to go by learning human wise studies also. This is one of the professor, right? For theoretical frameworks, you should read papers of Dr. Khatri, right? For PLS SAM papers, Professor Ringal, Professor Rasuli Vinish, these are the three people whose papers are there. Citations are huge. So make a benchmark, make a benchmark of your own paper, and then report that my R square was good R square, and this is also written by some of the papers of German scholars. German scholars, and in this paper, let me show you this paper. This paper of China and Germany, they have written this line. This is their model, very basic model. All emotions, vastness, professionalism, congruity leads to awe emotion. Awe emotion is there. Sometimes we go to Taj Mahal and awe emotion is there. What a place to visit, right? We go to Eiffel Tower. What is awe emotion? So awe emotion can lead to tourist satisfaction and behavioral intention to visit Guangdong in China. The biggest industrial town of China is Guangdong. So you have organized some sports activities over there. In Commonwealth Games in Delhi, you have an awe emotion of the stadium, right? In Narendra Modi Stadium of Gujarat, awe emotion was there. Look at the audience, 1 lakh audience, more than 1 lakh audience is there over there. Awe emotions. So the dependent variable is behavioral intention, and you will get R square of behavioral intention. You will get R square of tourist satisfaction. You will get R square of awe emotion. 3 R square you will get. But you know, most important R square is behavioral intention. So in this paper, when they applied SEM, they have got R square of how much R square they have got? They have got, now look at alternative hypothesis. All has positive impact on participant satisfaction. These are the hypotheses which you have to create. So when they were applying on data set, they got R square to the tune of, look at their R square, 25%. Satisfaction 259. Behavioral intention 38. Awe emotion 35. With these R square, these are genuine R squares. That doesn't mean you should bring more than 50%. They are writing that similar studies has to be reported by the researcher. You are the one who is doing literature review. You are the one who will note down all the R square. You are the one who will sort these R squares. You are the one who will create a range like this, 20 to 40%. They created 20 to 40%. And then they said our R square were within 20 to 40%. And therefore, we assume that our R square are within a good range. Never ever be afraid of low R square. You should justify. How can I go with 50 and above R square? If universe is doing this thing, will I bring R square from Mars? I'm living in Earth. And on Earth, these are the top studies. All the nations, 135. This 135 has given this range. So my R square is within this range. Therefore, my R square is acceptable. Come to third point. That is how you have to handle the toughest to toughest professors and editors. You can use this paper, use this page number also of this paper. They have given citation of Prayag also 2013. Now you have got two papers. So if in future you are entangled into low R squares, You can use Professor Rasuli Manish's paper, and Airbnb and hotel is the name of paper because he has lot of papers. You can find Airbnb paper. In SEM he has given this line. His R square in A category paper मिल गया ना, उसको आप खोल के देखिएगा 9% है R square, and he has justified with a citation that in social sciences R square you are able to determine, right? If you see people those who are working in finance, if I can determine Bombay Stock Exchange to the tune of 5%, am I not rich? I'll stop teaching because I will be rich. 5% Bombay Stock Exchange I can determine. It's a big thing. I will be more richer than Harshad Mehta. So 5% R square is also good R square. At least I have determined your dependent variable. The objective is, your objective is to tell who is significant, who is not significant, which independent variable is significant, which hypothesis is not significant. That is SEM. Okay. So in this SEM scenario, the first criteria is VIF inner, and second one is R square of dV. Make a range. Give 3-4 citations. With citation you can stop anybody, right? Yide Liu's paper of China, sports, Rasuli Manish, here at all, good R squares. Third one, you are supposed to yes. After these 6 points, I'll come to sample size. What should be the ideal size? Because that is going to be a most important question of final Viva boss. How you have determined your sample size? What is your sample size? They are the standard questions. Now we have got an answer. Very easy answer. So as far as third point is concerned, you are now going to mention hypothesis testing. Hypothesis testing. In hypothesis testing, you need beta, and you have to tell whether this beta was significant or this beta was insignificant, right? How you have tried to mention beta significant in the past? You must have read papers, how people are reporting significance and non-significance. Anji, anybody else? How you are reporting results are significant?
If the
P value is
more than p value is 0.05 less than 0.05
less than 0.05. If the p value is less than 0.05, we reject the null hypothesis.
Yeah, then it's significant.
And then we say that the results are significant. Competence leads to customer loyalty. Right? Question number 2. Can beta be negative? Can beta be negative? For example, this line.
Yes, beta can be negative. Yes.
Quality leads to competence. Can this be minus 30? Higher the quality, lower is the competence. Logically, I'm not saying. Statistically, I'm asking. Higher the quality, lower is the competence. Right? Can I say quality has inverse relationship with this purchase intention? Can beta be minus? Yes, beta be minus. Sure. What is beta? Beta is simply R. What is the range of R? -1 to +1. I am saying this thing because we are bombarded with one question. Sir, my beta was negative. What has been I have been done? Something wrong has been done. How can I convert minus beta into positive beta? I mean, response of the respondents, they have said that they just like this. Another question, let me give you a logical question. Risk leads to purchase intention. What should be the beta according to literature? Higher the risk, lower will be the purchase intention. Literature will say this, na? Literature will say minus 0.30. right? But if I get plus 30, that means I have done wrong research. No, it is saying that when the risk increases, purchase intention also increases. In financial market, when you take higher risk, you get more return. In Indian cars, nobody is wearing seat belts in the rear seats. They are total risk. Even with their families, they are taking total risk. In underdeveloped countries or developing countries, there is no seat belt on the rear seat of the car. They are taking higher risk. Higher risk, higher purchase intention of the car. ले रहे हैं risk. Jumping the red light, higher the risk, saving the time. Jumping the red light, this is what that means. If the people are saying that we want more risk and more purchase intention, then people are saying this thing. You should not be worried about that literature was saying negative was there. I must get negative. You are the one who are supposed to interpret and report what you have got. You should not be afraid of. You said that, sir, in my context, people are taking more risk. In literature, they are saying they have inverse relationship. I got positive. Report it. This is the finding of the study. So beta can be positive, beta can be negative. And let us say this beta is 30. So we report by p value. P value is a universal phenomena. When p value is less than 5%, when p value is less than 5%, p value is less than 5%, when t statistics is plus minus more than 2, t test is a more robust test than z test. Z की वैल्यू क्या होती है? 1.96. Z एक लिबरल टेस्ट है, t test is a stricter test. और हमने क्या पढ़ा है? We have studied t test is a test which is applied on less than 30 sample size. यही पढ़ा है? But ये नहीं पढ़ा, t test is also a test which is applicable on more than 30 also. Z test is a test which is applicable on more than 30. This is right. It cannot be applied on less than 30, but t test is a test which is applied on larger sample size and smaller also. And the minimum value of t is 2. The minimum value Z is 1.96. Who is more stricter criteria? T. SPSS gives you Z value or T value? T value. Software, any software is giving you T value. They should have given Z value. Why they are not giving Z value? But they take liberal value of 1.96. So if the T value is more than 2, P value is less than 5%, we say our results are significant. We are happy. But gone are these days. In present time, you have to draw confidence interval. What is confidence interval? What is confidence intervals? नहीं पता?
The alpha value of level of confidence interval is 1 minus alpha. Yeah, what level of confidence we have
What level of
regarding
confidence?
we have regarding the hypothesis? 95% or 99% like this,
95%.
or 99% like this, or 90%.
Okay, listen carefully now. Suppose you have collected data of 300 respondents, 350 people, and there is one model which you have created out of 2 years. In thesis, one model, one data set. How much observations you will get? One model, one data set, you will get one observation. So there is a process called as bootstrapping process. The bootstrapping process is that you run 300 data set. How many times? 10,000 times. You run this model 10,000 times. You run this model 10,000 times. Subsample. You create subsample 10,000 times. So when you run the model 10,000 times, you will get these observations. Now can you see? Many observations. Sometimes people are skewed towards left hand side. Some people are skewed to the right hand side. Sometimes you will get data here. These are 10,000 observations. These are 10,000 observations. 10,000. One data set. How one data set will be run 10,000 times? Look at bootstrapping. Bootstrapping means Hmm. Bootstrapping is not here. Okay, let me give you another slide where bootstrapping you can see. You should see bootstrapping, otherwise you will not get to know bootstrapping. Introduction, yes. In my previous slide, it is there. Have a look at the picture of bootstrapping. Look at bootstrapping, everybody. Just see the screen. Can you see left hand side? There are 9 respondents and there is one model. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can everybody see on your laptop? 9 people, one model, one data, one times you will get one observation. Look at subsample number 1. What is the change you can see on subsample number 1? 1, 1, 1, 5, 5, 6, 8, 8, 9. Do you know what has happened? What software has done? Can you observe subsample 1? What has happened in subsample 1? Software has removed the response of respondent number 2 and respondent number 3, and it has filled the response of 1 into 2 and 3. Substitution effect. Software has removed respondent number 4 and filled the data of 5 into 4. 6 is 6, 7 is 8, 8 is 8, 9 is 9. This is one another sample. Software does 10,000 times bootstrapping for you, and then Gaussian normal distribution curve is created. Poisson distribution, normal distribution. Third is, 3 distributions are there, na? Gaussian, Poisson, and normal, right? So if you say that I have run one data one time, it is not giving you a correct result. One data 10,000 times, and then from this observation, draw the standard normal curve. This is normal distribution curve, and this value is called as sample mean. Sample mean, yes. खुद रन करते थे, हाँ जी. That time they were doing 500 bootstrapping in 1980s. In 2015 the value was 2000 when we started learning SmartPLS 2. 2017 they said 5000. 2019 they said 5000. 2022 they said 10,000. So can I run 10,000 times? It will take me 1 month. Software does it in 1 minute, 60 seconds. 10,000 times. So that out of 10,000 times you draw a standard normal curve and then draw sample mean. These results are more robust than one data one times. Now got an idea bootstrapping? What is bootstrapping? Because bootstrapping will give you confidence intervals. Now, if here is 1 standard deviation, 2 standard deviation, 3 standard deviation, -1 standard deviation, -2 standard deviation, -3 standard deviation of the mean. Level of significance is 5%. What is level of significance? What is level of significance? 5%. We can commit error. Which error? Type 1 error or type 2 error? Type 1 error. That means at 5% level of significance, we record values 2 plus minus 2 standard deviation of the mean. Now this 2 is here. This 2 is here, right? This region is called as 95% region, and this region is called as acceptance region. This region is called as acceptance region. Acceptance नजर आ गया सबको? Where is 5%? Where is 5%? Huh? One-tailed and two-tailed. One-tailed and two-tailed. हम दोनों में से कौन सा tail check करते हैं? Two-tailed, right? So two-tailed means 2.5% here and 2.5% here. This is the rejection region. This is the rejection region. If somebody was within the standard normal curve, if somebody was here, look at this dot. If somebody was here, he was a good data. but he crossed plus minus 2 standard deviation. We can remove him from the data analysis. We may commit this error that the person was right, but we have rejected him. This is type 1 error. We are rejecting the true hypothesis. This is type 1 error. The person was well within the standard normal curve. वो यहाँ था, but we are rejecting him. This rejection of person who was within the standard normal curve is called as type 1 error. If I choose this person, this is called as type 2 error. What is type 2 error? Accepting the false hypothesis. Accepting the false hypothesis. Type 2 error. So out of the two, which error we commit? Out of the two errors, which error we commit? Researchers commit which error? Type 1 error or type 2 error? We choose to commit type 1 error. The person was well within the standard normal curve, but he was away from plus minus 2 standard deviation. Therefore, we have rejected him. Right? So this is called as alpha. This 5% is called as alpha, and this type 2 is called as beta. Okay. In SEM, if you have collected data for 500, you will not run 500 one time only. You will run 10,000 times, and on 10,000 times, draw this standard normal curve, and plus minus 2 standard deviation means 5%. Then you say, if my beta is within the acceptance region, my results are significant. This is the approach which is followed. Gone are those days when you are reporting with the p-value and t statistics. In present times, if you see Science Direct and other papers, people are not reporting t statistics, p-value. Everybody has got different paper. Everybody's PhD is different. Everybody's data is different. So they say, the developers say, everybody should draw their own confidence intervals and then check whether beta is falling between the confidence interval, not a universal benchmark of 5%. So if you see this screen, my beta must fall where? My beta must fall within the acceptance region. Like this is my lower bound. This is my lower bound, 0 to 2.5%. This is my lower bound. Lower bound is 2.5%. Then 95% came. And then this value is upper bound. Upper bound is 97.5. 97.5 plus 2.5 is 100. So out of 0 to 100, 95 is standard acceptance region from plus minus 2 standard deviation from the mean. My beta must fall within this acceptance region. If my beta is not falling in the acceptance region, results are insignificant. This is modern way of writing hypothesis testing. Fine. So 4 scenarios will happen. Now 4 scenarios will happen. What can happen with you? Let us say quality leads to competence. Quality leads to competence and beta is 0.30 and it is positive beta. Higher the quality, higher is the competence. Right? The lower bound is 25 and upper bound is 36. Okay. This is plus, this is plus. Whether my 30 is falling in between the two, 30 is falling in between the two. If 30 is falling in between the two, you will report my results are significant. Quality significantly leads to competence. This is how you are supposed to write SEM results. One is VIF inner less than 5, R square, make the range. 150 papers, 150 R square, make a range. Tell my R square is within the range. Even my R square is 15%. You cannot disqualify my low R squares. 3. My beta is significant or insignificant. If it is falling between the acceptance region, it is significant. Right? Scenario number 2. Scenario number 2 is your, yes. Quality is having an influence on competence. The relationship is 30, right? Beta is correlation, basically. The relationship is 30. If this 30 is coming in between this zone, this acceptance region, that means my results are significant and quality actually leads to competence. Okay.
But then, if it the lower and upper is out of the
Software will compute the When you will run 10,000 subsamples, software will draw plus minus 2. You have to only mention that draw this confidence interval at 5%. Software will ask you. Yes, SmartPLS will ask you 1%, 5% or 10%. 10% is plus minus 1 standard deviation. 5% is plus minus 2. 1% is plus minus 3. So out of the 3, in social sciences, 5%, right? Faculty in finance, they do with 1% level of significance. You cannot take chances, right? But in social sciences, marketing, HR, 5% is an ideal. So 5% means plus minus 2 standard deviation. This range software will give you, and software will give you lower bound and upper bound. You have to check whether my beta was within this range. But the condition is lower bound must be positive, lower bound must be negative, positive. All are positive, positive, and my beta was positive and it is falling. Scenario number 1. Scenario number 2, lower bound was plus 0.31 and upper bound was plus 36. 30 is falling in between the two. 30 is falling in between the two. 31 to 36 में 30 आ रहा है, नहीं आ रहा ना? You will say insignificant. Results are insignificant. 31 to 36, 30 is not falling. This can also happen. You will show insignificant. Scenario number 3. Beta is minus 0.30. Lower bound is minus 0.35 and upper bound is minus 0.10. Now tell me, 30 is coming in between the two. Between 10 to 35, 30 is coming in between the two. Minus 35 to minus 10. 30 is coming in between the two. Yes or no में answer है. Online audience. Minus 30 is coming in between minus 35 to minus 10. Yes or no? लोअर बाउंड भी माइनस है, अपर बाउंड भी माइनस है और बीटा भी माइनस. इट विल कम, है ना? इट विल कम. सो यू विल से quality inversely relate to competence. Higher the quality, lower will be the competence. Okay, and there is a significant relationship. Scenario number 4. Scenario number 4, this is very serious. Your beta was plus 30. Higher the quality, higher the competence. This was the hypothesis. And your lower bound was minus 35 and upper bound was plus 25. Now 30 is coming in between the two. मैं इसको यहाँ 35 कर देता हूँ. अब बताइए, 30 is coming in between the two. Yes or no? आ रहा है ना? जीरो आ रहा है इन दोनों के बीच में. Zero is coming in between the two. Can we say beta is 0? Can we hypothesize beta is 0? You cannot. Beta 0 थोड़ी होगा. If one value is minus, another value is plus, and 0 is incoming between the two, 0 is coming in between the two, results are insignificant. Results are insignificant. You cannot hypothesize beta is 0. Beta has some value. Beta cannot be 0. So 4 scenarios will happen. Software will give you. So this is step number 3. This is how people are reporting results. Look at the result of the same paper, all emotions. Look at this thing. Isn't she reporting beta confidence interval? That's it. Where are p value? Where are t values? Look at your laptop. Satisfaction, all emotion leads to satisfaction. Beta is 50. Is it falling between 42 and 57? Significant. Satisfaction to behavioral intention, 36 is falling 28 to 44. Significant. Professionalism to all emotion, significant. बड़ा पेपर दिखा देते हैं आपको. Look at this paper. PE. PE leads to BI. Beta is 2 to 1. Significant. Look at this H6. Focus on H6. Perceived risk leads to behavioral intention and the beta is minus. Beta is minus. Higher the risk, lower will be the intention. That was minus beta. This is bound to come. Is it significant? One bound is minus, one bound is plus. Zero is coming in between the two. Zero cannot come in between the two. Therefore, result is no. This is how you will report your thesis. All of you should write your thesis like this in the future. Yes, you can show asterisk sign 1%, 5%, 10%, 1%, 5%, 10%. You can show asterisk, but there is no need to show t value and p value. Right? This is fine. How somebody should show your look at first line. In IT enabled research, those who are going to work with AR, VR, blockchain, fintech, look at this first line. In IT related research, R square is considered to be larger if the value is more than 36 Wetzels. In JSTOR, this paper is there. Wetzels. If it is more than 36, it is a good R square. In IT related research, those who are going to do research on IT adoption, fintech adoption, 36. Right? So, is it? Hanji, sir bula rahe hain.
There's a question.
Yes, there is a question.
Fourth case and it's
Fourth case again and H6 again. Look at H6 and fourth case. This is paper H6. Look at H6. Perceived risk leads to behavioral intention. Beta is minus. But confidence interval you have to show. If one lower bound is minus, upper bound is plus, zero is coming in between the two. Confidence intervals, zero cannot come in between the confidence intervals. If it is coming, you will say insignificant. Results are there, but it is insignificant. Higher the risk, lower the behavioral intentions. Magnitude of the beta we have explained. It is very low, but it is insignificant. इतना भी कोई बड़ा केस नहीं है that risk will lead to behavioral intention. Okay. Paper, all papers are written like this. So I've shared this paper with you also. Whenever you will see these papers, what I have sent, you will see confidence interval beta. Confidence interval आपको दिखानी है. You are 2025, 26, 27. Right? Beta, lower bound, upper bound, results supported, not supported, significant, non-significant, yes, no. Okay, कर लेंगे. Coming back to
Sir,
next question.
Can I
Yes.
ask one question? Sir, why
Yes.
we are not reporting the t value in the table in the research papers?
No required. When you have drawn your own confidence interval like this, your confidence intervals are more robust way of checking 1.96 or 2. Your confidence interval is related to your data. You have collected 350 and
Yes,
this is
sir.
confidence interval of your data. 350 applied 10,000 times and now you say my beta was here, my beta was here, my beta was here. Your beta must be there.
Okay,
Right?
sir. Okay.
Benchmarks, universal benchmarks are this 1.96 or p value less than 5%. Right? So
Yes,
there is
sir.
no need to show p value and t value. Show this confidence interval approach that I have investigated hypothesis testing with confidence interval approach.
And sir,
Next,
it is necessary to report the lower limit and upper limit also, which
mandatory,
you have.
mandatory.
Okay.
Only then you can say na, that significant or insignificant.
Sir, can you please explain with the help of that in the SmartPLS software
In
where
SmartPLS, okay,
lower limit and upper limit, and where does mean the zero
where
does
this
not
value
lie
will come now.
between them? Yes.
Everybody open your SmartPLS. This is the interface which everybody gets when you start, right? Left hand side are the projects, right hand side are workspace, sample projects, documentation. Let us work on corporate reputation model. Corporate reputation model, everybody click on sample projects PLSM. Click on PLSM, sample projects. Can you see corporate reputation PLSM book primer? The thing which I have clicked on the screen, you should also click on this, your smart PLS. Go to sample projects, click on PLSM, and these drop down box will come. These are rough files where you can do experiment. Click on sample. Have you all given workspace? Many of you might not be getting because you have not allocated workspace. Workspace दे दी? अगर नहीं दिया तो workspace देनी पड़ेगी. Allocate a backup file folder and then click on this workspace. If your projects are not coming, click on new workspace. Click on new workspace and give a blank folder called as workspace and select all backup files will go into workplace. I have given my workplace, therefore my smart PLS is working. Done. Done. Click on PLSM. Click on corporate reputation PLSM book primer. When you will click here, have you seen something change in the left hand side? What has happened? A project is created and a model is also created. Click on option number 2. Click on extended model. Double click on extended model. Double click on extended model. Double click on extended model. Everybody has got this model. Is there any formative construct? Is there any formative construct? Make it reflective. Quality. Right click in the middle of quality. Right click in the middle of quality and click here invert. See my screen and work accordingly. Click on sample. A project explorer will come for corporate reputation. Click on extended model and make reflective construct. Quality is reflective. Performance is reflective. CSR reflective. Attractiveness reflective. This is an all reflective model, right? Paper will take black and white pictures. Research paper will ask you to give black and white pictures. Click on any of the construct. Click on any of the construct and click Control A. Select the entire model. Select the entire model and go to right side, extreme right side in tools. Is there a black drop? Coloring. Can you see coloring? Click on black drop. Click on black drop. Model is black and white. यहां तक सारे साथ में हैं. You can delete this. ये वाला ये नहीं चाहिए हमारे को, राइट? ये जो एडवर्टीजमेंट की हुई थी वो you can click and delete. This is the model. सी में मत बनाइए. Desktop, D drive, E drive. In C drive, software is installed. Backup files you should give in this D or desktop. Tomorrow, in another country, somebody has created a model. He can export as zip folder and give it to me. I can import as it is, and this model will come. Backup files are that important. I can transfer my model to another only by zip folder. I will export this as zip folder. He will import it as zip folder. Same thing will be there. Is there any single factor construct? Is there any single factor, single item construct? Find out. Single item नजर आ रहा है? CUSA, customer satisfaction. Customer satisfaction is one item. In PLSM, it can happen single item. Click on save. Click on save. Right? Come to this point when all are at the similar page. आपने एक सैंपल प्रोजेक्ट क्लिक किया, वो कॉर्पोरेट रेपुटेशन का था, आपने उसको ब्लैक एंड व्हाइट कर लिया है. All concepts are reflective. Now click on calculate. Click on calculate. Calculate PLSM. This option is CFA. PLSM is CFA. Measurement model assessments. Bootstrapping. Now you know what is bootstrapping. Bootstrapping is SEM. PLSM is CFA. Bootstrapping is SEM. Run PLSM and start calculation. Have you got output screen? Have you got factor loading? Can you see inner model? मॉडल में कैलकुलेट करना है, PLSM रन कर दीजिए, आउटपुट विल कम. कैन यू सी इनर मॉडल? कैन एनीबॉडी टेल मी quality leads to competence? What is beta? 0.356. रिफ्लेक्टिव बनाइए सारा मॉडल. आपका फॉर्मेटिव है कोई? सारा रिफ्लेक्टिव करवाना है ना. क्लिक ऑन द मिडल ऑफ द कॉन्स्ट्रक्ट, ऑप्शन आएगी इन्वर्ट. ऑल कॉन्स्ट्रक्ट्स रिफ्लेक्टिव. चले आगे. वेट. So the beta is 356. In SEM, which beta we use? In SEM, which beta we use?
DB.
Standardized beta or unstandardized beta? What is the role of standardized beta? Unstandardized is for forecasting, but unstandardized is for ranking, relative comparisons. Quality leads to competence 356. Quality leads to likeness 38. Who is better? Who is better? Quality is leading to competence 356. Beta is 356. Quality is leading to likeness 380. Which of the two beta is highest? 35 or 38? That means quality is more generating likeness than the competence, according to the respondents. Standardized beta is used for comparisons. Comparisons. We are doing comparison here. 35 is smaller than 38. Number 2, go to left hand side, graphical output. Find out where is graphical output. Can you see graphical output? This graphical output. Click on the drop down box of structural model. Click the drop down box of structural model. ये हमसे क्या पूछ रहा है? Blank, correlation, covariance, indirect, path effect. ठीक है? तो हमें क्या चाहिए? What do we need? We need path coefficients. बीटा चाहिए हमारे को. We need path coefficients. We need path coefficients. We need beta. We are working on inner model and inner model. So now everybody just see, you have asked the main question, where these values are coming, where are VIF inner, where is R square, where is hypothesis testing. Let us see one by one. Let us see one by one. Kindly click on quality criteria. Focus on my cursor on the board. Click on quality criteria. ये दिख रहा है? Click on collinearity statistics VIF. There are VIF outer model, there are VIF inner model. Which VIF we will see in SEM? Inner. Click on VIF inner matrix. Are these values less than 3.33? Inner model matrix, inner model matrix. Are these values less than 3.33? This table will go into thesis. First heading, and the name of heading will be multicollinearity in SEM. You have to write what is VIF, what is the formula of VIF. My VIFs are these, and you have to write none of the value is more than 3.33. There is no multicollinearity issue in my model. Next heading is coefficient of determination, quality criteria. First option, R square. Click on overview of R square. What is the R square of competence? 0.610. Satisfaction 29. Loyalty 56. Likeness 56. Which R square we will report? There are 4 R squares. Which R square we will report in? Dependent variable. Final dependent variable is loyalty. 56.2% of the loyalties are determined with the help of these independent variables taken together. 56% variance is explained in the DV due to these all independent variables taken together. It's a good R square. अब ये आपका 50 से ऊपर है, लेकिन इसके लिए भी आपको रेंज बतानी पड़ेगी. गो टू योर लिटरेचर व्यू. इसलिए जब आप लिटरेचर व्यू कर रहे हो तो आप अपनी एक एक्सेल, अच्छी एक्सेल बनाना. नंबर थ्री, go back to edit. Come back to this base model. Everybody. Now click on calculate and click on bootstrapping. 10,000 bootstrapping you have to run. Out of 10,000 bootstrapping, you will get beta confidence intervals. Click on bootstrapping. In bootstrapping, it will ask, by default software takes 5,000, but you will write here 10,000. You will write here 10,000. I will run my data of 344 10,000 times. And then normal distribution curve has to be created. At plus minus 2, standard deviation, significance level दिख रहा है सबको नीचे 5%. 2-tailed नजर आ रहा है, right? And we are going to work on bias corrected bootstrap confidence intervals. No bias. And click on start calculation. 10,000 faster, bias corrected, 2-tailed, 5% fixed seed, start calculation. Now you see software, how much time software is taking. Human beings can take 1 month, but machine is doing it for you. Mine is very slow now. On the last 15 days, it is teaching PLSM. So it has gone out of continuously, same topics. They are running bootstrapping many times. Yesterday night, it was running bootstrapping 10,000 times. but in your case I guess it will be faster. हो गया ना? So in the final results, click on path coefficients, final results, path coefficients, and confidence intervals. Third option. Bias छोड़ दो. You need O. O means beta. O means beta. 2.5 is lower bound. 97.5 is upper bound. लग गया? ये कॉपी करके आप पेपर में लिख सकते हो? लिख सकते हो. हाँ चल गया, मेरा भी चल गया अभी वो 10,000. हाँ चल गया. So the output is going to come. Output is there. In final results, click on path coefficient. From here, the option number 3 is confidence interval. In confidence interval, remove this word mean and bias. Just see the beta is 11. Attitude leads to competence. Beta is 11, and it is falling between 1 and 22. All are positive. 11 is coming in between the two. Attractiveness is positively, significantly leading to competence. Beta is positive and it is within the acceptance region. Significantly also it impacts. Tell me, is this value significant? Competence to loyalty. Competence होने से loyalty बन रही है? क्यों नहीं बन रही है? Lower bound is minus, upper bound is plus. It is not the competence which is leading to loyalty. Likeness से बन रही है? Likeness से loyalty बन रही है? 34 is coming between 23 and 45. Is it coming? इसके बाद 34 आएगा, 34 के बाद 45. It is significant. हमारे पास 3 इंडिपेंडेंट वेरिएबल थे लॉयल्टी के. जनता ने बोला है कंपिटेंस से नहीं बनती लॉयल्टी, क्योंकि हम आपको लाइक करते हैं इसलिए लॉयल्टी है. कस्टमर सेटिस्फैक्शन से बन रही है? सेटिस्फैक्शन से बनती है? हाँ बनती है. इसका मतलब आउट ऑफ 3 इंडिपेंडेंट people are likeness oriented people. People like you, therefore they are with you. It is not that because of your competence people are with you. They only like you. Okay, fine. Look at first option. First option, it is giving you T statistics and P value. Do you need this T value and P value? Do you need now? Do you need T and P? Not required. क्या करना है इसका? कॉन्फिडेंस इंटरवल अप्रोच से कर तो लिया. हु इज सिग्निफिकेंट, हु इज इनसिग्निफिकेंट, ये भी तो वही बता रहे हैं. बट हाँ, it will, P value will tell you 1%, 5% or 10%. Look at this value. This is 10%. It is significant at 10%. 10% पे वैल्यू होती है Z की 1.64. 1.64 से तो ज्यादा ही है. So attractiveness leads to competence, but at 10%. Okay, ठीक है. अब ठीक है मैडम, कहां से मिलते हैं ये? So Fazal, can you see from where you will get beta and confidence intervals? This is the interface, and you have to run. You have to simply run, calculate bootstrapping, and run 10,000 times. You know that my laptop has given problem. Will I waste my time again? No. Just look at, once you have run 10,000, look at this arrow. Look at this arrow. It has already captured PLSM as well as bootstrapping. This arrow, look at my cursor. There in front of this delete button, red button, the corner button, it has captured bootstrapping, it has captured PLSM. If I click on PLSM and open the report, it will give you PLSM results. If I capture here bootstrapping, it will give me open the report of bootstrapping. I need not to run 10,000 times again and again and again. I need confidence intervals and I need this lower bound and upper bound. That's it. That's it. The beta is more robust than 10,000. Beta becomes more significant also, right? At 5,000, you will get lesser observation to draw normal curve. At 2,000, you will get dispersed values. At 500, very dispersed value. Normal distribution curve is created at that point when lot of information is there, thick information. So 10,000 is highest.
Calculate PLS SEM. So why did we use this man factor and we say?
Okay, everybody just listen to the question. All are okay? Focus here on the screen. It's a very good question. When we ran PLS SEM, there were three types of algorithm. But we opted for option number 2. Why not factor? Why not principal component analysis? Why not factor? Why not PCA? Right? This is algorithm. CB-SEM algorithm is different. Covariance based SEM is maximum likelihood estimation. This is OLS. PLS is simply OLS, ordinary least square regression. PLS is not a separate name of type of regression. It is OLS. But even in PLS, it is a non-parametric SEM. There are three algorithms. We opted for path modeling. Why not factor? Why not PCA? So this question we read from the books of Hare and et al. Let me bring you to that slide. Why not others? Why not others? Handling measurement model assessments. Let us see measurement model assessments. This is measurement model assessments, and look at this. Can everybody see? First algorithm is what? First algorithm is path weighing scheme. Path weighing scheme. I said if there are multiple dependent variables and multiple independent variables, we are heading towards SEM, isn't it? Y1, Y2, Y3, and all the Y1, Y2, Y3 are related to each other. Some are acting as mediator. This is there in slide number, it is there, madam. I can tell you that it is there in slide number 23. It is there with you. So focus on which of the algorithm will be run by you in which type of scenario. Scenario number 1. When your objective is to check series of regression. In one model, there are so many regression models. Then we run multiple endogenous with multiple exogenous. Endo means DV, exo means IDV. When there are multiple endo, multiple exo, you run PLS algorithm, path modeling. Okay, this was developed by Professor Wald in 1980. OLS. Second, factor weighing and centroid weighing scheme. Do you remember centroid method? Have you ever heard of centroid method? Centroid. For example, this is the class. I have recorded your marks of your post-graduation classes and I took a mean, and your mean comes here near to first two students. That means that is the centroid. Anybody near to that centroid is a normal student, but anybody farthest to the group centroid is an outlier, right? Average marks is 40 and your marks is 10. You're far away from 40. Centroid method. Factor weighing scheme is based upon the correlation. If your objective is to maximize R square on the basis of existing correlations, you go with this factor weighing scheme based upon centroid method. The centroid of trust, the centroid of customer satisfaction leads to centroid of loyalty. If this is the objective, you want to check regression on the basis of centroid, then you apply factor weighing scheme. There is no significant difference in the results from factor weighing scheme, but path weighing scheme does not take into account the direction. factor loading R hota hai na? Factor loading is R. It tells about the direction, negative direction, positive direction. So factor weighing scheme, if you want to see the direction and if your focal point is on the basis of centroids, why people don't use this method? You know why people don't use this method? I said there are 25 students here. I took mean, but suddenly I added 4 faculty members of yours. What will happen to that group centroid? It will shift. That means 4 are outliers. They have shifted your centroid from this point to some another point. Centroid method is sensitive to outliers. Centroid method is sensitive to outliers.
So which case it is best?
First case, that is why people say we are running PLSPM. Never ever write from day today onwards PLSM. All of you will write PLSPM. Partial least square path modeling you will write. Hensler wrote this paper very angrily moved. He has written that paper that people are using PLSM. It's not a technique. It is PLS path modeling. You should write PLSPM. So I wrote a paper, we wrote a paper with PLSPM. Because tomorrow somebody can criticize. There are a lot of communities in LinkedIn. They are criticizing people are using PLSM. So you should in the future write that my algorithm is PLSPM. PLSM, stop writing this word PLSM. One is covariance based SEM. This is variance based SEM. Variance based SEM. So you write VBSEM. In abstract, you will write VBSEM, not CBSEM, VBSEM, variance based. Variance based is path modeling. No, our objective is that what is the centroid. If you want to take centroid as the focal criteria, then you use P factor. Irrespective of 1 dV, 1 IDV, forget it. Your focus is on the centroid of the customer satisfaction, customer loyalty. And the centroid is based upon the correlation of the items with the construct. Centroid method. Segmentation is done with centroid method. Segmentation. The segment of Gwalior, segment of Bhopal, segment of Indore. The group centroid of Indore might be different. The group centroid of Bhopal must be different. That means people of Bhopal has different group centroid. Indore must have different. Now, if you compare Bhopal and Indore with Delhi, their centroid is different. If on these basis you want to apply SEM, then you go with factor. And it will give you direction also. So Chin in page number 309 wrote this thing if your focus is on centroid and then you want to check R square. But when we have multiple predecessors, multiple endogenous and centroid is not the option, our objective is to find out R square run because this algorithm is not sensitive to outliers. Because centroid is not taken into account. What is the data of competence? What it leads to loyalty. As simple as that. Third, principal component analysis is a technique of EFA, exploratory factor analysis. You know everybody? Those who have applied EFA, they apply PCA method. There are so many 6 methods. If you want to mimic the result of CBSEM in PLSM, then you go with PCA method of path weighing scheme in terms of nomological network for model estimation. If you have drawn the this scale development process, scale development, you have developed your own scale, and from the nomological network you have brought a new factor, new scale, then you should go with this CFA according to principal component method. And if your objective is theory testing in PLSM, PLSM is theory exploration, CVSM is theory testing. With PLSPM, you want to test a theory, you will go with PCA weighing scheme. This is the third scenario. So generally what happens, we run with this best method and that is the default method also. Okay, somebody can say which algorithm you have applied and why. That can be a question, which algorithm you have applied and why. So your focus is on series of endo and exo and your focus is on group centroid, and your focus is to mimic the result of CB-SEM in PLS-SEM, then you go with PCA. Sometimes we apply EFA, then CFA, then SEM. For those individuals who is taking a longer route, they should go with PCA, even in PLS, PM. Question is solved?
So you have to bring IT for
15 minutes. Okay, everybody. So we are heading for three things.
Good afternoon, sir. Can you please explain once again a very elementary thing? If you can tell me how to apply to get the descriptive results.
Which results?
Descriptive analysis, sir. The basic descriptive.
Descriptive.
descriptive statistics.
Descriptive statistics. Descriptive is simply, let us say you have got a data. I'm giving you a data. Let us say this is smart city data set. Just have a look at
In,
a
sir,
data
I
set.
just want to understand the key, like what through the model,
Hmm.
like how do you get it
How do I get it? Just look at
from
the
the model?
construct of utility. Can you see this utility? Utility 1, utility 2, utility 3, utility 4, utility 5. Just do one thing. Insert insert a column here. Hmm. Insert a column here. Okay. Can you take average? Can you take average is
Yes,
equal to average average of these values, average of utility, right? And you can draw this two other values 4.4. Take this average value in SPSS and draw descriptive statistics, mean and standard deviation. You only need to take average value. जैसे ट्रैफिक है, environment है, governance है, every construct average value you have to take. So Z, just look at this value. Take this value of utility 5 and go to SPSS and draw descriptive statistics of average utility and click on option mean and standard deviation. You will get your value of descriptive statistics. Okay.
so can we get this result directly in PLSM model,
No,
like
no, no,
smart fitness?
no.
Oh,
As on date, it is not there. You can
oh,
take average and go to SPSS.
thank you.
So after tea break, we will come and see remaining 4-5 methods of SEM. 4 to 5 methods of SEM. So let us continue with point number 4. Now serious business will come. One is multicollinearity. Second is your this issue of R square. C is of hypothesis testing. Let us go for the fourth criteria. Fourth criteria. Fourth criteria. Have a look at fourth criteria. Number 4. In PLSPM, या तो आप ये नाम लिखेंगे, either you will write this name or you will write name variance based SEM, that we are applying non-parametric variance based SEM. Okay, so point number 4 is that what is the F square of the model? What is F square of the model? What is F square? Okay, just have a look at F square. Let us say my model is competence. My model is competence. Competence leads to customer loyalty. Likeness likeness leads to customer loyalty, and customer satisfaction leads to customer loyalty, right? This is our model, and based upon this model we have calculated r square. Let us say my r square was 0.48. My r square was 0.48. Competence leads to loyalty, satisfaction leads to loyalty, likeness leads to loyalty. When this model was there, my r square was 48%. I have to tell the academic word. I have to mention which independent variable is instrumental variable in my model. You are the one who are going to tell which of the three independent variable is instrumental variable in the model. And if future researchers are going to use my thesis or my model, I have to enlighten the another researcher which variable he should be very, very careful about. He cannot leave that particular variable. So f square is what is the effect size? What is the effect size? E. Effect size of independent variable on the r square of dependent variable. Effect size. For example, I gave you example of this photographer. The photographer, sometimes his camera is so good that your photograph is magnified with glory. Sometimes lighting effect is so good that even with an ordinary camera, photograph is very good. I have to tell that photograph was good because of light or because of camera. That is my role, which was instrumental for good quality picture in the photography. So I have to do one thing. I have to run this model and record r square. This r square is called as r square included. Write down. This r square is called as r square included when all variables were there in the research model. When everybody was there in the model. This is my r square. Number two, if I delete, if I delete competence, if I delete competence, what is my model? Customer satisfaction leads to customer loyalty. Likeness leads to customer loyalty. There are two variables in the absence of competence. Now I have to check r square. This r square is, let us say, 0.32. This r square is 0.32. We call it as r square excluded when competence was not there. When competence was there and when competence was not there. What is the drop of r square? What is delta r square? Delta r square is 0.16 and it has dropped. Is this drop significant drop? From 48, it becomes 32. Is it significant drop? That you have to check, right? So the formula of f square is r square included minus r square excluded, r square included minus r square excluded divided by 1 minus r square included. Okay. If this value, what is this value? 0.48 minus 0.32 divided by 1 minus 0.48. Somebody should calculate what is the value. 0.16 divided by 0.52. What is the value? What is the value? 0.3330.
0769.
307. 3 decimal places you should take in research. 307. If f square is less than, if f square is less than 0.15, if this value is less than 0.5, then you call it as a weak effect. You call it as a weak effect. Weak effect means competence was not so important in my model. Less than 0.15. 0.15. If this f square value is less than 0.15, I will interpret that competence is not a instrumental variable. It's not an instrumental variable. It was there. Literature suggested, so I took. But for R square, competence never gave so much of contribution. If this value is 0.15 and less than 35 then I will call it as moderate effect. I will call it as moderate effect. You know what is moderate effect? Moderate effect is competence can be considered as important variable in the model. If you are reading my paper, you should be very careful about taking competence. It in my study it was having moderate effect. But if f square is 35 and above, it is called as strong effect. It is called as strong effect. So researcher has to talk about that if I reduce competence from the model, then what is the value of my independent variable in terms of existence in the model? Existence. I am now checking about your existence in the model. You exist for me or not? How much you exist for me or not? Suppose you have got 3 friends. Which friend is instrumental? You have to check his loyalty. If your friend has got less than 515, your friend is there in your life. Your R square is 48. Your friend is not there and your R square drops. Your performance drops. That means your friend was important. Same is in the model. When a good faculty leaves an organization, then what happens to the research culture of the institution? Marks of the institution. When an important leader leaves, CEO leaves, who was transformational leader, he leaves. What happens to the organizational performance, which is DV? I have to tell you with F square. So software is going to check F square for each and every independent variable. This we have calculated manually in 10-15 minutes. But software does it for all the independent variables in 30-40 seconds. You are the one who are supposed to check that in which range F square value was there. That's it. This is point number 4. It is mandatory. No, your theory says it was important, but it was not contributing to the R square. When it was borrowed from the literature, it was important. But people said that it is not that important. Yes, we report this. Let me give you an example of the published paper. Look at this published paper. Look at this paper. Can you see F square values? Out of this entire paper, can you find any instrumental variable? Not a single paper. I have done hypothesis testing. I have done everything. But I have also explained that none of the variable was instrumental variable. Got it? Tomorrow you want to use this paper. Can you tell that is there any instrumental variable? No. No.
Okay.
It is a guideline for the future researchers that when you will create your model. Yes, sir.
Sorry.
So you
Okay.
have to tell about the future guidelines. You have to tell about I made a model and my model, for example, a microwave is there. Everybody has the microwave. There are so many buttons in the microwave. 10-15 buttons are there in microwave. Do we press all those buttons to operate microwave? We operate start, stop, temperature, right? But buttons are there, functions are there. In a TV remote, there are so many functions. But which functions are more important? I have to understand this thing. But function has there. F square की values read करेंगे with the help of ranges. Look at this range. This range. Look at this rule of thumb. 0 to less than 15. If your calculation comes to be less than 15, that means your independent variable was not instrumental towards R square of dependent variable. This test is for your IDVs. You cannot skip this test. It is mandatory. One is VIF, two is R square, three is hypothesis testing, four is your F square. So this is a published paper. Every published paper publishes um, this F square. Look at this paper. If you see this paper, can everybody see table number 4? Can you find out of the entire paper, is there any important variable from F square? Hmm? है ना? Which H7? Look at H7. This H7 is 0.235. From the entire paper, somebody can conclude that which variable is instrumental variable. This variable is an instrumental variable to measure perceived threat. Look at the bottom. PT stands for perceived threat and PS stands for susceptibility. So tomorrow, if you want to measure threat, you should not ignore susceptibility. Got it? In the morning, somebody asked me a question, sir, which variables to take out of so many variables? Now, can you find out when you are making that Excel table, are you not recording F square values? Out of every paper, let us say this Excel sheet, when you are making this Excel sheet, and in addition to R square, you will also make another column. You will also make another column. Any F square which has got above 15, and above 35. Find out paper number 1. Is there any instrumental variable? That means you cannot ignore that variable. Isn't F square of past research studies useful for your model? Anji. बिल्कुल बिल्कुल इसमें ऐसा होगा नहीं जनरली. Significant, if there is any significant impact, then it will make good R square. If it is making good R square, how can F square be low? I am important for this class. That means my beta will be high. If my beta will be high, definitely if you exclude me, F square will drop. Okay. So researcher, because you are at the nascent stage, everybody is at the nascent stage. This is the best stage to create excellent models. Find out which are the F square which are more than 35, which are above 15. Because when you assemble a car, you have to assemble important variables. So you can assemble from F square also. Note down F square, paper 1, paper 2, paper 3, paper 4. All papers, F square, then say, these are the instrumental variables. I have to focus first on these and then I will move to the next variables. F square is done. In strong effect. Yes, no, I have to write explanation. For example, this paper, I will write in the research paper. No, beta is A on B. F square is in the absence and presence of my importance. I am there and my beta is this. This is beta. I am not there. Then what is the beta and what is the R square? That is F square. You are checking in the presence and absence of independent variable. Beta is in the presence of A leads to B. So if you write these papers, look at this paper, hypothesis 7 was significant and F square was 23. In addition to this, there was another variable which was important. Can you find out? I guess no. Hello? No. No variable. So you can mention the F square has a small to moderate effect for most predictor of attitude and intention. This is what one line is there. One line is there. So try to calculate f square in thesis. Give formula of f square. Try to give formula of f square. Try to write the meaning of f square. Try to solve one f square, and then give your table of f square. In PLSM, this is model. Look at where these values are coming. Go to calculate and click on PLS. Go to calculate, run on PLS, and you will get f square values. Look at f square values. In this left hand side, in quality criteria, can you see r square, f square? Can you see f square? Look at this f square. Tell me any one variable which has got more than 35 in this entire model. Any variable which has got more than 35. The best part of software is if you click here, it will sort the things. Click on customer loyalty, it will sort descending order. The most important F square is customer satisfaction. Tomorrow you want to measure loyalty. You cannot ignore customer satisfaction in your questionnaire. Have you got the logic? Tomorrow you want to measure loyalty. You cannot ignore customer satisfaction because this value is 412. Any other variable? Any other variable? Customer satisfaction. Look at customer satisfaction. Is there any value more than 15? Likeness. That means you can also be very, very careful about the variable of likeness. If you want to measure customer satisfaction, likeness is also very serious variable. Rest of the variable you can be, apprehensive. You may or may not take. But this paper is suggesting you that likeness and customer satisfaction are important variables. Now it is your problem. You don't want to read this thing, it's your problem. Then you ask, researchers ask, sir, which variable should I take? People are writing and telling you that these are instrumental variable. Don't ignore them. If I don't know which to take, then it is my problem. Papers are there. You can download 150 papers and see how many papers have applied F square. Good papers in the last 4-5 years, F square is there. Note down what are the F square values, top, and make an assembly. Then create your questionnaire. If you work on important variables, that means you are making a good model. Try to make a good model. People are writing. Yes.
But given the theory, पहले के papers की values अच्छी आ रही थी. So now, sir, when we report the result and discussion section, could you explain कि हमारे में कम क्यों आया था कि
नहीं. For example, performance. Let me take performance. In previous 20-30 papers, performance was getting more than 35. But in your paper, it was only 13. So what is the conclusion? Will you take performance in the future? Yes, you will take performance. 1 or 2 papers might not give good values, but majority of the papers are saying performance is more than 35. So you go by overall majority of the papers. The citation you have to mention. Which is the citation? Citation is this paper. This paper. Cohen's citation is there. And if you open this paper, Cohen is mentioned. The effect size was determined by F square Cohen, which were found to be low. In this entire paper, everybody was low. That doesn't mean my model was bad. I am giving you recommendation. If you don't take this recommendation, then you are gone. Model will be questionable model. You cannot take a chance of your model. Find out what is the F square in the past studies. Take those clues and make your own model. No. IPMA is separate technique. It will tell you who is important and who is performing also. Here I am saying if I was there and if I was not there, should I presence and absence? only presence. IPMA is only in the presence. You are important, present, but you are not performing. You are also present. Here, absence and presence. So for star variables, F square will be high. Somewhere down the line, it will be high. Whose beta is high, F square will be high. So higher the beta, higher the F square, higher the IPMA. So all will conclude to the same point of. And now if you ignore this variable, then it is your issue, not anybody else's issue. Fourth point is okay. Let us come to fifth point. Let us come to fifth point. Please note down fifth point. Fifth point is model fit indices. Fifth point is model fit indices. Model fit indices. There is only one model fit indices, and the name is SRMR. It is called as badness of fit indices. How bad your model is. Can you hear from somebody you are taking a bad model? CFA you have done. SAM you have done 4 points. But you are reporting fifth point and you are saying my model is a bad model. Can you say your model is a bad model? Eventually in the end, when the end is coming of the movie, you are saying my actors were very bad. Storyline is very bad. You cannot say. You have to show my model is a good model. So how much bad your model can be? Your model can be bad to the tune of 8%. Your model can be bad to the tune of 8%. If your model is bad above 8%, then you are in a soup. Data collection done, reliability, validity done, hypothesis done, but you are working with bad model. How rude this is, hai na? Your model is a bad model. You cannot take a chance. And somebody says, sir, I will not report this thing because I had a bad model. You cannot do this thing. Because in CBSEM, there are a lot of model fit indices, goodness of fit, normative fit, Tucker-Lewis indices, confirmatory factor fit indices, CFI, TLI, and root mean square error of approximation, RMSEA. Root mean square error of approximation in CBSEM, your model can be bad to the tune of 10% and your model can be good to the tune of 90%. If bad is 10, good is 90. GFI, you know the cutoff values of GFI is 90. Goodness of it should be 90 in CBSEM. Here, if your model is 8% bad, you have to be good to the tune of 92. This PLS is more robust. So what is this 8% value? Standardized root mean square residual. What is this SRMR? From where these SRMR are coming? Okay, just see the picture which I am drawing now. Let me draw. Let us say you assemble three variables: competence, you assemble second variable customer satisfaction, you assemble likeness, and there was another variable loyalty. From literature view, you assemble four variables, right? You have generated four variables and these are important. F square also said these are important. Are these correlated variables or uncorrelated variables? Tell me. Why they are correlated variables? No. Should these variables be related variables or unrelated variables? Then why you are doing research? The price of the shoe in London is having impact of iPhone in Delhi. Related? No. Will you do this kind of research? Price of shoe, independent variable, purchase intention of smartphone in Delhi. Will you do this kind of research? No. You do research with related variables. Fine. That inherent correlation is there like this. Correlation, the sign of correlation is this. The sign of correlation is this. There will be some correlation between competence, loyalty, likeness, satisfaction, likeness. There will be some correlation. This also have some correlation. This also have some correlation. Some correlation will be there. So I will record this correlation. I will record this correlation value. Okay. I will record latent variable score of these variables. Latent variable scores, some scores of these variables. Then after assembly of variables, what is the role of researcher? When you assemble variables, what is the next step? You say competence leads to customer loyalty. Hypothesis building you do. Likeness leads to customer loyalty. This is what you do. This is what you do, isn't it? This process is called as conceptual model. Are you not making conceptual model and writing hypothesis? Theoretical is theory, on which theories they are coming. Now you will prepare H1A, H2, H3, H4, H5. Theoretical model, a logical model. The left hand side figure. What is the difference between left hand side figure and right hand side figure? Tell me, what is the difference between left hand side figure and right hand side figure? Can you find any difference? It's a theoretical model. It is based upon some logic. And that is untheorized model, mere assembly of variable. Mere assembly of variable. And this is the model, complete model. This model is called as saturated model. This model is called as saturated model. When you only assemble variables, it is saturated model because you have saturated your research. The table is there. You have reached to the point of saturation. Now I will start making the model. This model is called as estimated model. This model is called as estimated model. One is saturated model, your research is complete. Now you are making a meaningful model, theoretical model, which is estimated model. What do you think? What do you think between these? Correlation should be high or correlation should be low? Correlation between saturated model and estimated model should be high or low? Tell me. Figure on the left hand side and figure on the right hand side. What do you think? Correlation should be high or correlation should be low? Saturated model and estimated model. Mere assembly of variable. This is a classroom where we are sitting. We are sitting because it is an estimated model. Board is there. Light is on the ceiling. Floor has the tiles. Table is here. Everything is organized. This room is an estimated model. Before this construction of this room, what was there? Cement, sand, bricks, laborers, foremen. These were the things. That was saturated model. First of all, you assemble cement, you assemble bricks, sand, everything, you brought laborers. That is saturated model. But all of them created this estimated model. It's a very good room for teaching, right? What should be the correlation of saturated model and estimated model? Can you call bricks and cement same as like this room? No, no. It's a meaningful room. That was not meaningful things. That were mere assembly of variables. So if this correlation is more than 8, that means mere assembly of bricks is equal to this room. This is what you are saying. If your correlation is high, that means if you assemble bricks, you are saying, sir, this is room. Got it? That is called as badness of it. That is called as you are bad. You cannot say that mere assembly of cement and bricks is room. If you say, sir, bricks and cement are there, room is there, that means you are bad. You are not creating a good sense. This correlation can be tolerated till 8%. You said that first of all they will come and then room will be created. 8% is the maximum limit which is there in the books. So if you have more correlation, that means you assemble variables competence and you said I measured loyalty. You just brought competence and you said I have determined loyalty. You can determine loyalty on the left hand, this right hand side. You cannot determine. They are only correlations. They are impact. So this correlation has to be understood well by the researchers. So Professor Marco was teaching this topic from Berlin, from his room. So he was talking about SRMR. He said y1, y2, y3, y4, mere assembly of variables, mere assembly of variables. Look at estimated model. It's a theory-based model, logical model. The correlation between the two should not exceed more than 8%. The correlation between the two should not be more than 8%. This saturated model and estimated model should not be more than 8%. If it is more than 8%, it's a bad model. Okay. In PLS, if you run PLS, go to PLS algorithm. If you run PLS, you will get model fit. Check your model fit. In quality criteria, you will get model fit. This is model fit. What is model fit? Run PLS algorithm and open quality criteria option number 5. Sixth option, model fit. Click on model fit. You will report estimated or you will report saturated? Estimated. You will report estimated. Is it more than 8%? Your model is a good model. Your model is a good model. The problem with researcher is in the workshop, it is less than 8%. But when the workshop is over, you collect your own data, you run this model, it is 10%, 11%. And then you are pulling your hair, what has I have done? Then you are running from pillar to post. Okay. But first of all, you can copy this table. There is no need of NFI, chi-square, DG, DULS, only badness of it. And in a research paper, you have to write like this. You have to write SRMR. Look at this SRMR. The standardized root mean square residual are used to evaluate goodness of fit index. The value of SRMR for the estimated model is 6.8%, which is less than the critical value of 8. Therefore, I am good. That's it. This much line you have to write, I am good. Don't call it as a bad model. I am a good model. This paper, every paper, here they have SRMR. The standardized root mean square residual were applied as a measure of goodness of fit index. Who and Bentler? 40-50,000 citations are there. Value of SRMR below 8 is considered to be a best fit for estimated model. In the present study, SRMR for estimated model was 7.8 and below the threshold value of 8 to represent a good fit. You are good. You are not bad. If the value is less than 8, this is the 5th criteria of SEM. So when you will see any research paper, you just note down. They have written VIF, they have written R square, they have written hypothesis, beta, confidence interval, they have written F square, they have written this SRMR. Only these are there. You pick American paper, you pick German paper, you pick Australian paper, you will find these values. There's nothing more beyond which is going to come in your life. If new things are going to come, so you can learn it. But as on 2024, these are the things. Coming back to the second last aspect, how many points we have covered for SEM? 5. Now let us go for 6th. Write down. So one by one, you can write 20-30 pages with SEM and 20-30 pages with CFA in thesis. Thesis writing is done with 100 pages data analysis. Out of 100 pages, you can spend 40-50 pages easily with CFA and SEM. Literature review 150 pages. Data analysis 100 pages. RM section 15 pages. Discussion 25 pages. Introduction 15 pages. That's it. Data analysis should be of 100 pages.
You make it so easy.
No, this will come. This will come when you will bring your data, import the file, create the model. You have to simply run calculate PLS. These values will come. You have to copy, paste, and write, start writing. Fine. You have to write even the diagrams. There are a lot of things which software is giving. Look at this reliability validity. You are showing this alphas, AV, but they are giving bar chart also. Take this bar chart also. There are so many things which you can fill in the thesis, but in research paper, meaningful things are written. Paper is of 8,500 words. So you write meaningful things, but thesis you can put anything, put water in lassi, enhance. So these things will come. That is why I'm saying point number one. Next time you will do SEM, these will be the points. Pick any paper of earth. These are the things. We are also not writing nothing more than this. So coming back to this sixth point. Now this is very important. This is called as predictive relevance. This is called as predictive relevance, which cannot be done in CVSEM. Okay, CVSEM has some limitation also. Their objective is to find out R square. Here objective is also predictive relevance. Can I generalize my model into different contexts? Can I generalize a study of India in Asia? हम बताएंगे ना, we will tell, you will tell with this point. Is it generalizable? You will tell. This is the name of technique. Whether the study of Russia is applicable in Europe, can it be generalized? Whether Indian study is applicable in Southeast Asian nations, whether BRICS nations study is generalizable in ASEAN nations, you have to tell from this own thesis also. This is called as predictive relevance for generalization. Now remember your reading. People are writing and helplessly they are writing in the end. My model was done in Delhi NCR. Researcher has to conduct in Mumbai, Pune for better generalization of the result. Next time you will not write this line. You will prove with a technique, and the name of the technique is PLS predict. PLS predict. It is one of the most important inventions which Professor Galit Shmuli has done. She is a master professor. We have seen how respect she is earning from the developers of SmartPLS. Finest professor. So Ganesh Muli, every time when I read her paper, something new comes out. So she said that let us say you have collected data for 500 respondents. Good enough. You collected 500, 700, 800. So she says that divide this data into two pieces. Okay. One is called as training data, and second one is called as testing data, on which testing is done. Now remember your smartphone, remember your car. Whenever you buy a new product, OKs are written. Why those OKs are written? Because the product is duly tested before it is sold to the customer. So you have to test the data and tell whether my model can be generalizable or not. How it is done? She said 90% of the data and 10% of the data is an ideal range for doing this testing procedures. When you have higher data set, take 10% of your data set for testing purposes. So model will be run on how many people? Model will be applied on 450 and model will be tested on 50 respondents. So software, let me tell you how the software is going to pick this cherry of 10%. Let us see paper of Galish Muli. PLS predict. Paper. Look at this paper, and you have to read this paper for. I mean, for every point you see there is a paper. For F square there is a paper. For R square there is a paper. For VIF there is a paper. When you go from this workshop, make folder according to the point wise. Isn't it? Your life will be easy. PhD is actually easy, not difficult. Ganesh Muli from Taiwan, National Tsinghua University. So she wrote a paper from 18th of February, revised 18th February, accepted 26th February. Within 8 days, paper was accepted because this is the finest masterpiece for reporting PLS predict. Joseph Hare is there. This is that take out data like this. Take out data like this, right? Fold 5 means divide 100 by 5. What is the value? 20. 20 is testing data, 80 is training. Fold समझ लग गया? What is fold? If you divide 100 by 5, ratio is 80-20. If you divide fold by 10, ratio is 100 by 10 is what? 10. Then ratio is 90-10. If your data is big, use 90:10. If your data is small, use 80:20. Now you know 80:20 how it is coming? Number of folds. So software will take out roll number 1, roll number 2, roll number 3, 4, 5 diagonally from the data set. They will pick randomly every 5% out of the total data set. This ratio is 80:20, right? The shaded portion is testing data, remaining portion is training data. Now, then they say this data will be repeated. This data will be repeated. How many times? They said run this data 10 times. 10 times run this data. Bootstrapping is done 10,000 times, but run this data 10 times for better average. Okay. Where are our Excel? This is our Excel. So on 450, you run y is equal to alpha plus beta 1 x1, beta 2 x2. You run this model. Whatever model you have brought, run it. And record alpha, and you record beta. Beta 1, beta 2, beta 3. Please tell me what is the meaning of beta. Who can tell me from the audience itself what is the meaning of constant and what is the meaning of beta? And it represents what?
Coefficient of prediction. We have to put the values of variables for the future prediction. We have to put x1, x2 values, and it will be constant.
Now,
Beta will be constant.
have you heard of slope? Beta represents what? Slope. Whose the slope? Alpha is the intercept. That means beta is the behavior. Behavior of x1, behavior of x2. You run the model and record the behavior, right? They said you run the model and record the behavior. These are the two behavior of your audience, of your major audience. Now, instead of going to Mumbai, Pune to validate results of Delhi, you can use this data on testing because you have already taken out some data for testing. From your own sample, you can tell whether it is generalizable or giving same response or not. With the same alpha and beta, you run regression on 50 respondents. Okay, the behavior is recorded from the bigger audience. With the same alpha beta, you will run the regression on 50 respondents. Okay, and what you will do on this 50 audience, you will run the model 2 times. First of all, you will run the model with some theory. You will run the model with some logic, right? You will run theorized model. You will run the theorized model, theory based model, and this is called as PLS-SEM model. This model is called as PLS-SEM model. 2 is it will run without any theory, without any logic, and this is without any understanding. And this is called as LM. LM stands for linear model. LM stands for linear model. All independent variables on DV straight away, without any logic, without any argument. Run all IDV on DV. Here, right? So, first of all, on this 50 people, you will run with logic, and then what you will do? You are going to measure customer loyalty. You will measure that, suppose these are the three statements of customer loyalty, and this is R square, and what will you get? Error 1. You will get error 2. You will get error 3. You will get 3 errors, right? When you will run this model on 50 without any logic, again you will record errors. Again you will record errors. Error 1, error 2, error 3. Now tell me whose error should be high? Whose error should be high? Without any support. No? Let us say this value is 0.30, this is 0.40, this is 0.50. This value is 31, this value is 42, this value is 55. Now tell me, is it a good scenario or a bad scenario? Is it a good scenario or a bad scenario? Why it is a good scenario?
Those values are error values.
These are error values. 31, 42, 55 are error values.
Scenario.
It's a good scenario.
It's a bad scenario. Because
How it is a bad scenario?
because ultimately the items are responsible for explaining the stuff, and if the
Error is a good thing or a bad thing?
it's a bad
Bad thing. 30 is bad, 31 is bad. Where it is bad? Without any logic. Compare E1 with E1. Compare E1 with E1. Kindly compare E1 with E1. If you run with logic, the error is 30. If you run without logic, error is 31. Is it a good scenario or a bad scenario? This is logic. This is without logic. Logic में, in logic, error should be less. Write down. In theorized model, error should be less. In theorized model, error should be less. Whenever you apply theory, your error should be less. Can you say that I applied theory and I got high errors? My model is a bad model, will you say? No. Smooly worked on comparing errors. She said that on testing data, if without logic, your errors are increasing, then your model is generalizable. Second scenario, error 2, logic is 40, without logic is 42. This is greater than, it's a good scenario. Error number 3, logic 50, without logic 55. 55 is greater than 50. In all the three scenarios, it is a win-win scenario, right? In all the three scenarios, it is a win-win scenario. If all the three scenarios, it is a win-win scenario, 3 out of 3, you are having a good scenario. That means you will report high predictive relevance. This is how you have to report the results. When your errors are high in without logic model in all the statements, then you call it as high predictive relevance. If out of 3, there are 2 good scenario and in one case you have failed, you will write moderate predictive relevance. If 1 out of 3 there is a good scenario, then you will write low predictive relevance. If 0 out of 3 is the scenario, What should you write? No predictive relevance. No, low, moderate, high. These are the four scenarios. And then if your paper is writing high predictive relevance, you will never write the line, my model is not generalizable. You can say a study of India can be regressed into Asia. Okay. All the three scenarios, error of theory based model was high. Not a good scenario. You applied theory and your errors are high. Ah, moderate predictive relevance. Yes, to some extent. Low means to a lower extent. It may not be generalized. No means absolutely not. In all the scenarios, you can win. So, if you see regression, I'll tell you how LM is applied. See the screen, just see the screen, and in the screen, this PLS predict. The first paper was Galish Muli's Elephant in the Room. When she wrote this paper in Elephant in the Room, she brought everything into this generalizability. Her research novelty was generalizability. What people are saying, I am not generalizable, she wrote on generalizability. With Soumya Ray from Taiwan, right? So he was teaching this course from his classroom, how PLS predict works. They said, this is the masterpiece paper. And then they said that our objective is not to find R square. Our objective is to find out that what is the predictive accuracy. Fitting is R square. Prediction is PLS predict. You calculate R square, it's only a fitted model. Fitting, how Y and predicted Y are calculated, but it is not, fitting is not prediction. Prediction is, look at this sample model, training data, that is a training data. Y is DV, X is IDV, right? You run the regression on training data, you record alpha beta, this is the parameter, you record the alpha beta, and then you record this alpha beta, on holdout cases. Look at this drum. You run the sample training data, and then you record alpha beta. With the same alpha beta, you apply it on testing data. This out of sample is testing data. And then you find out Y2 hat predicted Y. So training data, production data, and validation, if they are giving same result, then you are saying that my results are significant. They say, look at the upper side of the model. It's a logical model, corporate reputation logical model. Look at upper sides of the screen. It's a logical model. Look at lower side of the model, illogical model, without any theory. You take any number of items, all number of items of the model, and run it straight on the DV, loyalty. That is LM. Whose error should be high? Upper segment or lower segment? Lower segment. If lower segment errors are high, you are generalizable. To give this argument, people accepted that yes, she is talking sense. She is talking about errors. She is talking about testing. During testing, she is saying that this is theory, this is no theory. In no theory, my error should be high. Just like engineering students in NITs or IITs, they are doing some testing in the laboratories. Chemistry students, they do testing before giving some conclusion. So you need some data for testing. If you don't take out 10% of the sample, how can you do testing? It is similar to the people, those who are doing testing in non-medical and medical also. Doctors are doing testing on frogs, and then they are operating human beings. Frog is available to them. This is a frog which is you are going to take out of your data, 10% data or 20% data. Then run this frog. Logical, illogical. I am not going to run. Software has the algorithm, it will run. This entire dictation which I have given will be run in 30-40 seconds. And then you have to compare the errors. So three types of error will come. Three types of error will come. Look at MAE, MAPE, RMSE. If the residual are normally distributed, if the residual are normally distributed, bell-shaped curve is there, you will use RMSE. Write down. If the residuals are normally distributed, you will compare RMSE errors. If skewed data is there, skewed means residuals are not normally distributed, you will use MAE, mean absolute error. But software never gives MAPE. You know why? Look at denominator. Can sales be zero? कोविड में सेल्स जीरो नहीं हो गई थी, बंद ही हो गया बिजनेस. वाई इज डिपेंडेंट वेरिएबल. कैन सेल बी जीरो? सेल जीरो हो सकती है. सेल्स कैन बी जीरो. इफ डिनोमिनेटर इज जीरो, it will give infinity. This y, MAP, yi, this can be zero. It can be zero. If it can be zero, so infinity can come. Therefore, two of the method will be there. Bell-shaped curve is there, RMSE. Bell is not there, MAE. Now let us go to software and let us see from where these things are going to come. Open your model. This is your model. Right? Come back to this model and go to calculate. Come back to this model, everybody, and go back and click on PLS predict. Click on PLS predict. It will ask you two things only. Rest of the calculation it will do. Just see what this software is asking. Number of fold, 100 divided by 10. If I use 100 divided by 10, what will happen? What is the ratio? 90:10. If I do this 5, 80:20. You can modify. Slower sample size, 80:20 ratio is recommended. 300, 200. Because you need more data for testing. 300 ka 20%, 60 you need. So more the data for testing, you need more frogs to test. If you get less number of experiments, then you may fail. People in Ranji Trophy, people before going for IPL, they do so many practice sessions. Right? Every cricket team goes for practice session before opening for any international match. That is testing time period for them. Many people don't perform in practice sessions. So they are taken as player number 13, 14, 15, 16. So this is number of words. This is number of repetition. So let us take 10 and the model will be run 10 times. Start calculation. Now you know what is happening. Software will divide 90-10. Software will take 50 alpha beta. Software will run theory. Software will run untheorized. Software will give all the errors. This is the time which we has taken. Software has taken 30 seconds. It took only 10 seconds. Entire lecture has been done in 10 seconds. Look at final result first option. Final results first option. Final results first option. Where is customer loyalty? Where is customer loyalty? CUSL 1, CUSL 2, CUSL 3. Isn't it? There are three types of loyalty. There are two types of error. RMSE, MAE. RMSE, MAE. Which error you will take? क्यों? कहां पर देखा आपने? You have to copy this. For those who are writing thesis, you have to copy. Now is the time when first assumption of regression can be investigated by you. Regression has four assumptions. First assumption is residual must be normally distributed. Assumption number 2, multicollinearity. Assumption number 3, autocorrelation. Assumption number 4, heteroscedasticity. This is cross-sectional data. We report only 2. If residuals are not normally distributed, we can go with PLSM. If residuals are normally distributed, you can go with CVSEM. CVSEM is parametric SEM. It can be applied only if you meet the first assumption of regression. PLSM is non-parametric. If skewed data is there, you can apply. Look at histogram. Look at histogram. In histogram, click on CUSL1. Now you tell me whether bell shape is there or not. Bell ban gayi hai? Bell is there. Is it normally distributed? Which error you will choose? RMSC or MAE? RMSC. Will you not copy this figure and paste in the thesis? Yes, because it is telling you first assumption of regression also. You say I am writing win-win scenario. My residues were normally distributed and I am applying PLSPM and I can do prediction which I cannot do in CBSEM. So this is bell-shaped curve. Only PLS predict is only for the DV. F square is only for the IDV. Model is a model, but in bits and pieces you are doing operation. PLS predict has to be seen only for the final DV. Look at customer loyalty 2. Is it normally distributed? Can I see outlier? PLS predict is also used to find out outlier. Can you see outlier? Where is outlier? Both hands, not on the right hand side. Left hand side. Who are the outliers? Can you name them? Who are the outliers? Int 2, customer loyalty 2. 4.966, 4.524. These are outliers. You have to identify them. You have to delete them from your original data set and then run regression. You cannot work with abnormal people, those who are here. You cannot work with abnormal people like here. Bell is ending here. Bell is ending here. These people are outliers. Identify them, delete them, kill them. Otherwise, they will kill your beta and R square and everything. Got it? PLS predict is a tool to find out outliers also. So let us find out who these people are. What is the value here? 4.966 and 4.5 customer loyalty 2. Okay. Look at this MV prediction errors. MV prediction errors. Click on MV prediction error, option number 1. Click on MV predictions and errors. Focus only on loyalty 1. I'm just hiding these. Focus on loyalty 2. है ना? What was the value? 4.966. Just click here. Click here. Roll number 254 is outlier in the class. Roll number 254 is outlier in the class. Okay? This value is given 10 times because repetition was done 10 times. You have to remove this person from your data set. 254 number respondent is an outlier. He is not a good person for my analysis. You are supposed to kill this person. It is multivariate outlier. Who else? Roll number 210 is an outlier according to loyalty 2 statement. Roll number 16 is outlier. These 3 people are outlier. Okay. Look at customer loyalty 1. Customer loyalty 1. This side it is fine. That side loyalty 1. What is the value? 4.294. 4.294. This is loyalty 1. Who is this person? Roll number 303 is an outlier. Remove this person. So statement wise of the dependent variable, you can find who are the incorrect persons in my data set. Remove them. Otherwise, they will remove you. ठीक है? Outlier कर सकते हैं ना? This is SEM. You can handle multivariate outliers. तो जब आप डेटा कलेक्ट करके आए 400-500, पहले PLS प्रोडक्ट ही रन कर लो. Run PLS predict on the first instance, find out outliers, remove them, then do data analysis. And last, look at this value. Now you said we will see RMSE, isn't it? We will see RMSE, we will not see anything else. So this thing will go into research paper and focus only on loyalty. Is it a good scenario? Tell me, is it a good scenario? The error here is 1.298. The error here is 1.3. It's a good scenario. LM, non-theory model. Error is 1.3, error is 1.2. Good scenario? That is why color is green. This is 1.5, this is 1.54. Error is high. It's a good scenario. Error is 1.52, error is 1.56. In all the three scenario, we won. So you will write high predictive relevance. My model is generalizable. This loyalty model is generalizable. Even if you bring new data set, it will give same result. I have done it on testing and I have done it on errors based testing. Right? I have done testing in the laboratory. If you actually go to Mumbai, Pune, it will give similar results. What I have done in India, North India. Right? So if you see any paper, good paper, in the good paper, PLS predict will be there. Look at this paper. Adoption behavior. This is adoption behavior. PLSM, theorized model. LM, linear regression, non-theorized model. The final DV was adoption behavior. There were 3 items and 3 error. 1.162. This is error. 1.205. Increased. It's a good scenario. 1.21, 1.24. Good scenario. 1.10, 1.157. Good scenario. In all the 3 good scenario, therefore we have written that this model is generalizable model. This model which you are looking here is a generalizable model. Adoption behavior is a generalizable model. Mobile application in Delhi NCR can give you same result in Mumbai, Pune also, and in Chennai also. It is a generalizable model. People here in Europe or in Taiwan, they are doing technique-wise research. Somebody is working on generalizability. Somebody is working on IPMA. Somebody is working on this R square. Somebody is talking about F square. Everybody is giving his invention. But PLSM has encapsulated all these things. That is why it is a robust software, and people took this software hand in hand. They said, yes, we need this software because you cannot calculate F square, but it can. You cannot do 10,000 bootstrap. It will. You cannot do this divide the data, take the alpha beta, then run theory wise, then run John. It's there. You have to take this, report this, and write the paper in table number 5, PLS predict. So PLS predict is sacrosanct, mandatory. All these 6 points you cannot skip, which we have covered. No parameter should be left by you. All parameters you should pass. And this is how after this thing, if you see paper discussion comes, now discussion, implication, theoretical implication, managerial implication, then IPMA. Okay, then conclusion paper is over. One day you write IPMA, one day you write theoretical implication. So paper can be written in 3 months, provided you have a good model and a data. People write 2 papers in a year, but you are research scholars, you should write 8 or 9 papers in a year. Okay. So this is Sam. Tomorrow we will cover higher order model, straight away higher order model, reflective, and then mediation moderation, plus IPMA. We will cover this IPMA. You all need to draw this diagram, IPMA. Right? This IPMA is very important technique. It is giving results like BCG matrix, star variable, dog variable, like strategic management. It is there just like for strategic management. In one of the paper, so if you see The faculty earlier she was there in Christ, now she is in IIM Ranchi, Radha Yadav. Model she brought, it was her model, right? And we have applied IPMA. Rest of the things are there, everything is there, but we have written IPMA. And the interesting facts of IPMA was, students said, the students in private universities said, the most important variable on x-axis is teacher. This is the data of students, but teacher is not performing. This is the finding. Students, 450, 750 students said the x-axis is importance, that is performance. They said the most important variable is teaching. This is teaching, this is teaching. The most important on x-axis is teaching, but teacher is not performing well. कितनी बड़ी finding होगी? We brought a model and they said private universities teacher don't teach. Actually don't teach. So we have to understand how this thing can be done. It can be done in 10-15 minutes, but logic is of 30-45 minutes to understand. Tomorrow we will come with higher order. Tomorrow we will come with IPMA, mediation, moderation. So the email which you have got received, save those email and save those PPTs. These PPTs are borrowed from Germany. We have gone there and brought there. Right? Nobody, we know that nobody can go, but now it is with you.
Already sent it to the.
And papers
Hello,
are
sir.
there. Start reading these things. Yes, please.
Sir, I have a doubt.
Yes, go
Sir,
ahead.
in the case of CB sum, it is using error term, but in the case of VB sum, it is not using the error term. So, is it a deficit of the VB sum, or how it
No,
works?
no. The objective of variance-based SEM is to investigate what is the impact of independent variable on the variance explained in dependent variable. Right? Our objective is to apply series of multiple regressions simultaneously. At every stage of the model, calculate R square. While in covariance based SEM, the objective is to find out and maximize the value of R square, and overall, you have to compare what is the, they have applied on chi-square test, what is observed matrix and what is implied matrix. So basically, they compare observed matrix with implied matrix, and then they say, is there any significant difference between observed and implied? So it is not that it is a good regression, that is a bad regression. Your objective is theory testing, CVSEM. Your objective is theory exploration, PLSM. Your objective is to check R square, maximize the R square in the standardized model, CVSEM. You are doing with adapted questionnaire, PLSM. The choice of, you want to do prediction, PLS predict, PLSM. Lot of things are there in
Sir,
PLSM.
if there is a model, I want to check the model as well as I want to make a prediction. Then which will be better, sir?
PLSM, prediction, PLS predict. Go with PLS predict.
Okay, sir. Okay, sir.
R square is simply fitting. Simply fitting the data with Y and predicted Y is not going to give you predictive relevance. With the testing and training data, you can check the predictive relevance. Therefore, PLS predict is a better technique of relevance and done in PLSM. Okay. So tomorrow, what is the time?
So we start at 10.
10. Sharp 10. Because if you come by 10:15, majority of the higher order model would have been discussed. Okay. Higher order model is
We have to cover multi-group also.
that is moderation. Multi-group is moderation. Serial, parallel, everything is mediation. Okay, take care everybody. See you tomorrow. And make sure that you start reading the research papers one by one.